So in this question, it's given a rock is dropped from a 100-meter high cliff. How long does it take to fall? A, the first 50 meter, and B, the second 50 meter. Okay, so let me draw the situation here. Assume this is the 100-meter height, right? So this will be the first 50 meter, and this will be the next 50 meter. Now at this point, when the rock is dropped, its initial velocity will be 0 only, right? Assume that while falling, see, the direction of gravity is this, right, downwards, and the rock is also falling from here to like this, and finally it will cross this 100-meter mark at this point, right? So see, assume at this, after crossing 50 meter, it has reached the velocity v1, and after crossing 100 meter, it has reached the velocity v2, right? And also we can assume that the time taken from for this rock to fall for the first 50 meter is t1. So I am writing just t1, and for the next 50 meter it will be t2, right? So now I am writing the equation. See, let me write what's all given here. Given that, see, total height is given, which is 100 meter overall, and apart from that nothing is written. We need to assume. Okay, so for the first 50 meter, for the first 50 meter, I am writing the equation. See, its initial velocity is 0, and we need to make a relation with respect to time. So we are using this relation, which is s equal to ut plus half at square. In this case, we are talking about first 50 meter, so s will be 50. U, its initial velocity is 0, so it will be 0 plus half. A here is g, and I am taking the value of g as 9.81 into the first 50 meter, the rock has taken time t1, so I am putting t1 square. So if I have to solve this, I will get t1 square equals 100 upon 9.81. So this will give us a value of t1 equal to under root of 100 upon 9.81, which is 3.19 seconds. Or let me write it clearly. This value is 3.19 second. Right, so we have already calculated t1. Now for the complete 100 meter, I am writing the equation. See, I am trying to write the equation from the initial position, which is this one, right? If we want, we can write the equation at this place also. From here to here, the next 50 meter we can write, but for that we have to calculate the velocity, the value of v1, right? So I am taking from the initial position, which is where velocity is 0. So for the complete 100 meter, I am writing the equation again, s equal to ut plus half at square. S is 100 in this case, and initial velocity again is 0 plus half into g, and t square. Here the total time will be t1 plus t2 square, right? So if we solve this, we'll get a value of t1 plus t2 as 200 upon g under root, and we can feed the value of t1 from above, which will be 3.19 plus t2 will be under root of 200 upon 9.81, right? So if we solve this equation, we will get 4.52 minus 3.19 as t2, which will give us the final value of 1.33 seconds. So this will be our final answer.